projects I posted in week one. I'm going to show you how I create the post and delete routes. This is the post route I created for my contact. It validates that all the required fields like first name, last name, email, favorite email, and link are provided. If any field is missing, the API responds with an error. When validation is successful, the data is added to the database using the subcommand method, and the ID of the new contact is returned in the response. Here is the post request to add a new contact. After sending the request, the API responds with the ID of the new contact. This confirms that the contact has been successfully added. Here is the new contact in the database. The data matches what was written in the post request. This is the push route for updating an existing contact. It takes the contact ID from the URL and the updated field from the request body. If the contact is found, it updates the database using the update one method and responds with a success message. Here is the push request to update the contact email and favorite email. When the request is sent, the API confirms the contact was successfully updated. This is the delete route, which allows for removing a contact by ID. The route uses the delete one method to find and delete contacts. If the contact is not found, it returns a 500 not found error. Here is the delete request to remove a contact. The API responds with success message confirming the contact has been deleted. The contact is no longer in the database, showing that the delete request was successfully executed. I have demonstrated how to create and test the post, put, and delete routes for managing contacts in the API. In this next step, I will integrate Swagger into my projects to document the API and make testing easier. Swagger provides a user-friendly interface that displays all my API endpoints in one place, allowing developers to test and understand the API without needing external tools like REST. Let's go step by step to set it up and test it. To get started, I installed Swagger UI Expert and Swagger AutoGen. These libraries allow me to generate documentation automatically and display it in a visually appealing way. It immediately updates itself in my package.json. Next, I created a file named swagger.js. Here, I configured the API documentation by specifying the title, description, host, scheme, and the endpoint file that contains my API routes. This file will be used to generate the swagger.json file. I ran the swagger.js file, which automatically generated the swagger.json. This file contains all the API documentation in JSON format and will be used to render the Swagger UI. created a new file called swagger.js to define the Swagger route, the API versus docs, endpoints to serve the Swagger UI, where user can view and interact with the API documentation. I integrated the Swagger route into the main route in index.js. This ensures that the API documentation is accessible from the main route of the application. Now, I started my server to test the Swagger UI locally. I open the Swagger UI in my browser. This interface displays all my API endpoints, including their method, parameters, and responses. It also allows me to test the endpoints directly. I tested the test endpoint for contacts. The response shows all the contacts in the database, confirming that the API and Swagger UI are working correctly. After deploying the application, I updated the host field in the Swagger configuration to reflect the deployment URL. I then regenerated the Swagger JSON file and we deployed the app. Here is the Swagger UI on my deployed application. It displayed the same interactive API documentation as before, but is now accessible online. I tested the get endpoint for both retrieving all contacts and retrieving a specific contact by ID. Both worked correctly, confirming that the API works as expected on the deployed platform.